Hello, my name is David McMahon, and I'm one of the math teachers here at Southwest High School. We're starting Unit 5 of our year, and this unit is all about coordinate geometry. Today we'll be talking about section 5.1, which deals with distance between points, midpoints, and also gradients, which are like slopes of line segments. You can see here we've got a list of the entire, all 6 sections from Unit 5. Let's go ahead and get started. You might need to add an entry into your table of contents for section 5.1, distance, midpoints, and gradient, and then open that notebook to a new page. We'll be adding 3 different sections. Okay, so my sections look kind of like this. I've got my notes that I took from before. And also within each section, you're going to do one example. I'm going to give you in each section a choice of a couple of examples. And then the video also kind of details solutions to those. So for our first part here, what we need to do is, if we're going to talk about coordinate geometry, we have to define what a coordinate means. Try and make sure everybody understands this. Anytime you've got a pair of numbers that's in a bracket separated by a comma, or I shouldn't say anytime, most of the time, that is a coordinate point. And then the first number, the x value, refers to sort of a distance either right or left from what's called an origin. So I'm going to just write right/left here. And then the second number is the y value, and that's a distance from the origin either up or down. Now when I say origin, I think what we need to do is really kind of carefully define that. If you have a coordinate plane like this, you can talk about the x-axis. Okay, so that's just really a chart of like all the different possible locations for x. So if I tell you that x is 4, then you could put 4 somewhere on this number line, especially if we tell you that 0 is right in the middle. So x equals 0, right in the middle. And y equals 0 is right in the middle too. So this is the coordinate point, 0, 0. That's called the origin. And then we likewise, we'd have a y-axis kind of running up and down. And that y-axis is goes through the point 0, 0. And then the positive numbers would be up, and the negative numbers would be located below that origin. So anytime you've got a coordinate point, we put it somewhere on there. So if I just randomly pick a point here, we would have to move to the right a little bit and up a little bit to get to this pink point. And the directions for how to get there can be rewritten as x, y. How far you move to the right and how far you move up in this case. So if we're going to try and talk about distance between 2 coordinate points, I'm just going to place 2 points on my page. You should do the same. The distance between those points would be defined as the shortest distance, like that. And in order to calculate that distance, we're going to need to know something more about the location of those 2 points, and specifically the location on a coordinate axis. So I'm just going to draw in a coordinate axis with the y-axis and the x-axis. You could put in those 2 coordinate axes cross at 0, 0. That's usually a nice thing to put on your graph. And then in order to find that distance, really what we're going to have to do is measure the horizontal distance between those 2 yellow points and measure the vertical distance between those 2 yellow points. And then, horizontal and vertical, they meet at a right angle. Hey, that's a right triangle. We're going to use a relationship for the side lengths of a right triangle. You might recognize it. A squared plus b squared equals c squared. Yeah, the Pythagorean theorem. or Gogu's theorem, or the Babylonian theorem, or the distance equation, or the sum of the squares of the two shorter sides is equal to the square of the longer side. Lots of different ways of writing this. But a squared plus b squared equals c squared. A lot of people have seen that before. Let's try and use that. So we gave you the equation, a squared plus b squared equals c squared. I'd like you to choose one of these two problems and then try and find the distance between the coordinate points. You might need to pause the video right now. I'm assuming that you've come back now after pausing the video. You've tried one of those problems in your notes. I'm going to go through the solutions to both problems very quickly here. So looking at that problem on the left-hand side with the graph, when I looked at this, the distance is that black diagonal distance, and I measured the red horizontal distance between the two endpoints and the blue vertical distance between the two endpoints. And then I'm going to apply my favorite theorem, my favorite equation about a right triangle. So in this case, the distance squared is equal to 7 squared plus 3 squared. I can just calculate 7 squared and 3 squared is 49 and 9, add them together and get 58. And after I do that, I can apply a square root operator on both sides of that equation to get d by itself. Now, of course, I could leave my answer as the square root of 58, or I could type that into a calculator and get an approximate value of 7.6. I can take a look at the second problem as well, and I got to be honest. When I see two coordinate points, or even just one coordinate point, I have a picture in my head of where that coordinate point or where those coordinate points would be on a graph. So -3, 7, that's a little to the left and then up. And then 5, -4, that's a little to the right and then down. So I can kind of see the distance between those 2 points. I can see what it is physically, but I don't know what the calculation is quite yet. It helps me to have that picture in my head. So when I'm thinking about that picture in my head, I want to measure the horizontal distance and the vertical distance between those coordinate points. And to find the horizontal distance, I've got to think about the distance between the x values. So the distance between -3 and +5. That's 8. I could do 5 minus -3 to calculate that, or I can just think, this little distance here from x equals -3 to 0 is 3, and this other distance from 0 to +5 is 5. 3 plus 5 is 8. I want to measure the distance between the y values as well, so I'm looking at y equals 7 and y equals -4. The distance between them, directional distance would be -11, but I could think of this distance as just 11 as well. I need to put this into a little bit of a formula. The diagonal distance squared is going to be equal to the horizontal distance squared plus the vertical distance squared. I put in the 8 and the -11, full well knowing that -11 squared, same thing as 11 squared. Those are both 121. So then my distance squared is 64 plus 121. That total is 185. Apply a square root operator and get the square root of 185, or approximately 13.6. Those are the solutions to those two examples. And I do need to point out that all I did was just look at I could have ignored the graph and just figured out the distance between the two x values, figured out the distance between the two y values, and then plugged that into my formula. It would have been the same work. Talk about the midpoint of a line segment. So this is adding another section to your notes here. So write down midpoint of a line segment. And then we're going to do this in terms of pictures, really. So I think before we had said that if you have two endpoints and you connect those two endpoints with a segment, we can talk about the midpoint of those two endpoints. And we had some definitions from a plane geometry. We had some notation of putting in little marks on the lines. We're not going to do that this time. We're going to look at this in terms of coordinate geometry. So I want to talk about the coordinates of these points. So I'm going to call the first coordinate point x1 and y1 with a comma in between. And then the second coordinate point is going to be x2, comma y2. Now, if we're talking about coordinate points, we should have the coordinate plane drawn in too. So I'm just going to draw in a sketch of the coordinate plane of our x-axis and our y-axis. Now the midpoint, that midpoint is like the middle, okay? But it's really the middle of the x values and the middle of the y values. So I want you to write down the midpoint is, and then we're going to have two phrases here, middle of x value, or the middle x value, and then comma, the middle y value. And rather than thinking about that in terms of a formula, you certainly could. You could, the middle x value, that's going to be adding together the two x values and dividing by 2. And the middle y value, that's going to be adding together the two y values and dividing by 2. Recover. There we go. So I can write down a formula like that, but I got to be honest, I don't think about that formula. I think about finding the middle value. And I guess I do use that formula. Okay, so here's our two examples. What I would like you to do is choose one of those examples and then try that on your paper now. You should probably pause the video. I'm assuming you're back. Let's take a look at the solutions to both these problems. We'll do the graph first. So in that graph, we've got a couple of coordinate points. I can kind of see that the midpoint is right in the middle. Okay, I think it's at 1, 3. But if I want to try and really figure out if that's at 1, 3, I'm going to look at the coordinate points on the endpoints, and then I'll find the middle x value and find the middle y value, and then determine that the middle x value really is 1, and the middle y value really is 3. So the coordinates of the midpoint are 1, 3. I can do that same sort of thing with our second example. In my head, kind of think of what that picture looks like. And what helps me here is to think that when I find the midpoint, the x value, the x coordinate of the midpoint really should be between 0.4 and 12.1. If I do some mathematics and I wind up with an answer that's outside of that gap in between 0.4 and 12.1, I know I did something wrong. Likewise, you got to try and find a y value between 6.7 and negative 4.7. So I got that picture in my head, but then I'm really just finding the middle x value, and I'm finding the middle y value, and then figuring out that the midpoint of 6.25, comma 1 is between the two endpoints. Now, it's okay to have a decimal value somewhere in your answer. It's going to probably happen a lot. Let's talk about gradient of a line segment with 2 given endpoints. So now we're moving on to the third and final section here. So the gradient of a line segment with 2 given endpoints. Boy, we can talk about this in terms of the slope. Okay, so I think maybe that's another term that you've heard before. Usually, then gradient is just another way of saying that. So slope or gradient, I think of it as a fraction. So it's a fraction or you could say a ratio. And really that fraction, it describes steepness. So I'm going to say the fraction that describes steepness. And let me kind of explain what I mean here. Some people, when they talk about slope, they talk about rise over run. So I hear that phrase a lot. And then other people, they look at this and like, you know what? Slope is the change in the y values divided by the change in the x values. And then there's still other people that say, well, why would you write change in y values? We can do that in symbols. We can write delta y or triangle y. So I write triangle x, it's delta x. That stands for the change in the x values. And if I'm going to name the coordinate points, x1 comma y1 and x2 comma y2, the change in the y values is really going to be y2 minus y1 over x2 minus x1. And you could write y1 minus y2 as long as you do the same order in the denominator as well. Now, just in terms of like picturing this in my head, I'm going to draw it in just a couple of coordinate axes here. I think you should do the same. Because I think it's important to be able to glance at a line or a line segment and immediately know, is that a positive slope or a negative slope? So if we draw in something like this, this is a positive slope. And the way I think about this is that if I choose 2 points on this line, moving from this point on the left to the point on the right, the y values go up. This is a bigger y value on the right. And the x values also go up. This is a bigger x value on the right. So the change in y is positive and the change in x is positive if we move from the point on the left to the point on the right. Now, if you go the other way, if you move from the point on the right to the point on the left, the change in the y values would be negative. You have to go down. And then the change in the x values would also be negative. So your fraction would be negative over negative. That's still positive. It's a positive slope. If you look at the other graph, and we can draw in another line, but this time down and to the right, this is a negative slope, using the same argument. Okay, so if I choose 2 points, really we'll just look in one direction here. If I talk about this point on the left and I want to travel over to this point on the right, my y value has to go down, and then my x value has to increase. So I have a decrease in y values and an increase in x values. My slope is going to be a negative value over a positive value. Negative slope. Okay, I want you to pick one of these 2 examples and then give it a try. I'm assuming you're back from pausing the video. Let's take a look at those solutions. For the example with the graph, I didn't even name the coordinate points. I counted boxes. So I know, looking at the coordinate point that's on the furthest left and then moving over to the coordinate point that's furthest to the right, I have to go down 4 spaces and then to the right 8 spaces. This is a gradient of negative 4 over 8. Of course, you can rewrite that fraction in an equivalent form without any common factors as negative 1 over 2. Either way works. The second example, I'm not even going to draw the picture. I think gradient is rise over run, which is I got to think about the change in the y values and the change in the x values. Focusing on those y values, we're going to move from -16 to +9 on the y-axis. So that means the y values are going up 25 points. And I could also think of the x values. I'm moving from x equals -14 over to an x value of +4. The x values are increasing by 18 units. So I could think of this in terms of change in y over change in x and kind of use the formula there too. 9 minus -16, that's measuring the distance between the y values. And 4 minus -14 is measuring the distance between the x values. So then the slope here winds up being 25 over 18. Okay, so hopefully in your notes now you've got 3 different sections, 3 examples. I'd like you to just, and you don't need to write this down, this might be part of your assigned practice, but this is a slightly more complicated application. So if we have a curve in the road that is defined by some coordinate points, you can approximate the length of that curve. And I guess you would have to do this by finding the distance between the first pair of points, and then finding the distance between the second pair of points, and finding the distance between the third pair of points, and then adding them all together. We can also talk about another challenging example where we tell you the endpoint of a long line segment, and we tell you the midpoint, and then you kind of reverse engineer where that other endpoint is. There's a lot of ways of doing this, but I'll leave that kind of challenge problem to you. Okay, I hope this has been a good introduction to Unit 5 and talking about distance between points, midpoints, and the gradient of a line segment. Hope you have a great day.